Welcome to the Modal Shop's Frequency Response Calibration tutorial. This presentation discusses how to perform a frequency response calibration using the Model 9155. Measuring the sensitivity and frequency response of an accelerometer is the most basic and common test performed on a sensor. Any change to the performance of the sensor will eventually be identified by one of these two tests. A sensor specification will state the nominal sensitivity of the sensor along with the allowable deviation from this sensitivity. The nominal sensitivity of the sensor is defined at a specific frequency referred to as the reference frequency. The frequency response of an ideal vibration sensor is a flat, straight line. The frequency response of an actual vibration sensor, however, deviates from this. The measured amplitude frequency response of a sensor is typically scaled in percent from the reference sensitivity. The comparison or back-to-back method is performed by mounting the sensor under test directly to the surface of the reference standard, which has a calibration traceable to one of the national labs. The fundamental assumption made is that the acceleration of the reference accelerometer and the acceleration of the sensor under test is equal. A typical step sign calibration is performed by exciting one individual frequency at a time and using the known sensitivity of the reference standard and the voltage output of the two sensors to determine the sensitivity of the sensor under test. Alternatively, multi-sign or broadband excitation may also be used. Under these techniques, multiple frequencies are excited simultaneously and a fast Fourier transform, or FFT, is used to transform the time domain responses of the reference standard and sensor under test into their frequency domain components. The true response of an accelerometer can never be measured with complete accuracy. In other words, there is also some level of uncertainty associated with performing a calibration. Part 21 of the ISO 16063 standard lists which factors contribute to uncertainty and should be considered when making an uncertainty statement. Most components are dominant either at high frequency or at low frequency. Running a frequency response calibration is a quick, simple process. Once the sensor is mounted and connected to the system, completing the calibration involves 3 steps. 1. Select the sensor that is being calibrated and the test being used. 2. Run the calibration. And 3. Save and print the calibration results.